I am continuing on with the setup of an assembly model for putting in some springs for a dynamic analysis. In the last video, I was working on an engine body assembly. I created a part simplified rep and put some points in there for the springs later on. In this video, I'm going to go into the valve train subassembly. Let's open it up in its own separate window. And I am going to get the mechanism working in here, at least part of it. I'm going to get the pin connections working so that the cam exhaust and cam intake both rotate, and then put a gear pair connection in between them. You're going to see I'm going to come across some interesting problems along the way. So let's start off with this part here. I'm going to edit definition. Right now it is fully constrained, so it's not capable of rotating. Let's go to the placement tab. There are three constraints. We have a coincident constraint, looks like between a couple of axes. Then we have another coincident constraint between a couple of planes that prevents translation along that axis. And then there's a third coincident constraint that prevents rotation along the axis. I actually want rotation along the axis, so this is the constraint I need to delete. And when I click delete, it automatically turns on the option to allow assumptions, which will still lock it. Let's uncheck the option, and by this red arrow on here, you can see that now there is, or actually not the red arrow, but the red sort of like ring. You can rotate about this axis. I want to turn this into a connection, so I will use this button on the dashboard in order to do that. Tells us that our connection definition is complete, so I can hit the check mark to complete that. Let's do that for the other side. Let me select the component and then edit definition, and I'll go to the placement tab. Once again, it's the third constraint that eliminates rotation about the axis. Let's delete it and then uncheck the allow assumptions, and then use the button to convert the connection to constraints and vice versa. Now we have our connection definition complete. Hit the check mark, and if you take a look in the model tree, the two glyphs or little symbols next to the components indicate that we have mechanism connections. So normally in a perfect world, I should be able to jump over to mechanism mode by going to the applications menu, and I get this error. The highlighted connections are not defined between two rigid bodies. If you continue, they will be suppressed. If I click on the accept button and then say try to rotate something, it's not moving. Nothing is moving in here. And if you take a look in the message area, I get a warning that you may not drag a component, or excuse me, you may not drag a model belonging to the ground body. So something is going wrong here. I should be able to rotate those components. They're the very first two real components in the model tree, but I can't. Let's close out of here and try to figure out what is indeed going wrong. And so let's take a look at the first real component, the cam exhaust, and I will right click and then go to information and reference viewer. And I can see, okay, so here's the components, and I can see that its parent is the valve train skeleton model. And I can see that, all right, looks like it's using some kind of reference. I'm guessing that's a data sharing feature and an axis. If you expand, you can see what exactly it's using from them. If I move this aside, I might be able to position everything in my window so as I highlight over, I can see. So it looks like it's using a plane from this data sharing feature and also using an axis. But the interesting thing here is that I see that that same skeleton is actually a child of the component. If I expand this, I can see that, okay, looks like there's another data sharing feature in the skeleton that is a child of that part, plus a whole bunch of different points. Let's take a look at the skeleton model in its own separate window so that we can try to diagnose this. I'm going to select the skeleton model, hit the open button. I always like being in full screen. And when we take a look at the model, oh, we can't see anything. Let's go to the layers, make everything visible, and turn on all the different datums. And okay, maybe we don't want the datum planes because they're really cluttering up the screen. And nominally, it looks like we have a lot of geometry that is defining those two actual components. But if I go to the reference viewer, I'll go to information and then reference viewer. I can see that if I take a look at the information, I'm going to make everything wider just so that I can see everything. Here's the skeleton model. The skeleton is a child of the cam exhaust and the cam intake, those two components with the pin connection. I'm actually kind of surprised that this is not a circular reference, but PTC did a lot of stuff to make the code more robust. Also, if I expand this in here, we can see that, okay, it's using all these different curves from the cam exhaust and the cam intake as well. If I expand in here, I can see that these are all the different entities that are the children of all this stuff over there. And again, I can see these two things which say exhaust spring surface and tent spring surface. These look like data sharing features. Maybe I see some other one, the up cam exhaust surface, up cam intake surfaces. So let me go over to the model tree. If I click on here we have the data sharing feature that grabs all the surfaces from the exhaust cam. I can right click on it and go to information reference viewer, and I can see, okay, the parent of this feature, which again is some kind of data sharing feature. I never memorized the icons. Its parents are the cam exhaust part itself, and also for some reason a chamfer in the cam exhaust part. And then we see that the child of this is some over cam surf copy CR in the skeleton part. So this other skeleton in another part uses those references, but maybe they should just reference the cam exhaust surface itself. This is causing a problem because these two entities are basically copying from a component in almost a circular fashion. So I'm going to delete those two features. Let me right click and delete it. And yeah, I'm probably going to have a problem in the cam cover, but I'll deal with that later and just change the references so they grab right from the cam parts themselves. So that took care of some of the references. Let me go back to the previous assembly. And now we can try to drag. And I click on it. Once again, you may not drag a model belonging to the ground body. All right, still, what is the problem over here? Let's once again go to one of the parts and then information reference viewer. And we see that the valve train skeleton also is using a bunch of points. It's using has some points that are referencing the cam exhaust part. Let's take a look at those points in the valve train skeleton. So it's points 8 through 15. Let me expand this and go to point 8, and we'll go to reference viewer to figure out its parents and children. And by the way, one thing I want to mention, the reason I do these different videos where I'm taking some existing model and trying to fix it and do other things to it is because in my experience, I spend more time updating models and updating models from other people rather than working on new models myself. So it's really important to know how to be a detective in someone else's parts and assemblies. So here I see the part, and its child is a component, one of the exhaust valves, component ID 107. So if I click on here, let me see if I can rearrange the screen. You can see that it's this exhaust valve over there. Let's close out of here and let me locate that in the model tree. All right, here is the exhaust valve. Let me repaint so that it's the only thing that is highlighted in here. So if I right mouse click and hold and go to edit definition, This one is weird. So, okay, so we see that we have a coincident constraint, which puts it along this axis. And then there's another coincident constraint where a surface in the valve shim in this subassembly is constrained to this datum plane ADTM 56. And the weird thing is, if I go to the information for this, it says the status is not in geometry. And other information about this indicates that it's some kind of internal plane. If you take a look for this ADTM 56, we're not going to be able to find it. I'll go to the search tool. Let's look for a feature. Let's look for a feature. Let me change the name in here to ADTM star and then find now. There are no features in this assembly or its submodels that start off with ADTM. So I'm not sure what kind of crazy work that they did in here. So the next thing that I'm going to take a look at is getting rid of all those different coincident constraints between that internal assembly datum plane and the surface in, what was it, like the valve shim or something. Let's edit definition. And this is something that I was going to need to do later on anyways. Let's go to the placement tab. I really need to have a cylinder connection that allows translation and rotation for that component. Right now we have a coincident constraint between a couple of axes. Then we have this other coincident constraint between the flat surface and this internal datum that, if I highlight over here, you can see that PNT8 is even highlighting on the screen. So somehow that assembly reference internal plane that I can't even locate is using that datum point. If I delete this and then use the convert button, we get a cylinder connection. That's good. Let me hit the check mark and let me now go to, here's the point again, and if I right click and go to information reference viewer, we see that this point no longer has any children. Hey, great, now I can delete that point and click the OK button. And now I need to go through and do that for all these other different points and the different valves that they are connected to. So basically for all the intake valves, I'm also going to edit definition, go to the placement tab, go to the second constraint that has some kind of weird internal assembly datum plane, and then delete it, and then go to the convert button to get a cylinder connection and hit the check mark. I've got to do that 14 more times, so I am going to put an edit into the video over here and come back when everything is done. Okay, I am back. I have converted all those different constraints to the cylinder mechanism connection. Again, you can see that because of the glyph on the side. Before I move on even further, there are a bunch of suppressed springs in here. And if I right click, I can't resume or open those different parts. So I don't know where they are. I don't even have them. I'm not going to need them for the work that I'm going to do. So while I'm at it, I'm going to delete all those different parts. All right, so that is good. Now let's go back up to the skeleton in the model tree. We've got all those different points that are children of the cam exhaust or the cam intake parts. Let's right click on them and then choose delete, then click the OK button. And so now we can say, hey, can we drag the components now? So I'll hit the drag button and click on here, and they still don't move. You may not drag a model belonging to the ground body. All right, so what is still belonging to the ground body? Well, all right, so let's take a look at the cam exhaust. I'm going to right click on it and then go to information and reference viewer. And we can see for the cam exhaust part, one of its children is this component, the gear exhaust. So the gear exhaust component is assembled to it. And if we right click on it, then set as current, here we have the gear exhaust part. and I can see one of its parents is an axis from the valve train skeleton. And so this is one of those weird things in a mechanism that can cause you trouble. By having this component that's assembled to the cam exhaust also have a parent from the skeleton, it's locking up the whole entire thing. Let's take a look at some of these different intakes. So here we have the gear intake. I am going to edit definition. And if I go to the placement tab, I can see that, all right, there's an axis in the gear intake that's assembled to an axis in the valve train skeleton. Then we have a coincident constraint where we have a datum plane from the gear intake assembled to a datum plane from the cam intake, and then a surface from the gear intake assembled to the cam intake. So this particular part is assembled both to the cam component and to the skeleton model. This is what's locking, another thing that is locking up the assembly. So let's remove these different references. And again, it's always a good idea if you can restrict the references for a component to be assembled only to one other component. That's generally a good thing. So let me try to query select to grab the cylindrical surface from the gear intake, and then from this surface. Now we're fully constrained. Let's hit the check mark. Let's do the same thing for the gear on the other side. Edit definition. Go to the placement tab. Again, we have a coincident constraint to the cam, another coincident constraint to the cam, but this one is to the valve train skeleton. So this is a really, really kind of tricky thing that will mess you up. I've come across this a few times in my career, and sometimes it can take a while to figure out what's going on. And it's because, hey, if you assemble a component to some assembly level datums or some skeleton datums, they can be considered part of the ground. So the components that they are assembled to end up being part of the ground as well. Just something to keep in your back pocket. This is actually something I went over in my video on mechanism best practices. All right, let's hit the check mark over here. And before I start moving stuff around, let's go to the drag. And these components in their initial location are assembled great so that the teeth are interlocking. So I want to keep that as a snapshot. Let's hit the camera icon. Let's rename this. I'm going to use it later on. This will be my starting position. And then I can close out of here. Oops, actually I didn't mean to close. I'm going to keep it open and then attempt to drag. So I'll click on here. Hey, this one is capable of rotating. And then click on this component. Hey, this one is capable of rotating as well. That is great. Now we can put in our gear connection. And actually, before I put in the gear connection, let's open up the gear in its own separate window. Here we have a curve, and I'm going to make that curve visible. So it looks like they created a curve in this part to represent the diameter for the pitch circle, which is awesome. Let's measure that, seeing as I'm going to need it for the gear itself. I will measure diameter and then pick that particular curve, and here's the value. What's nice is you can right click on the value and choose copy to put it on your clipboard, so that way I can just paste it rather than having to write it down or remember what that value is. All right, let me close out of here. Let me close out of the skeleton model. Let me go back to the valve train assembly. Let's put in our gear pair connection. I'll go to Applications, Mechanism, and still highlighting a problem with a couple of the components. If you continue, they will be suppressed. So again, mechanism tells you when you have a couple of different issues. And I'm going to take a look. There are these two gears over there. Man, just one problem after another. Let me figure out which ones they are. Okay, I had to figure out what is going on with these two particular components. Here is the deal. If we take a look at this particular valve spring from one of the exhaust valves or intake valves, that is okay. If we edit definition, we can see that this particular spring is assembled to the skeleton and to the skeleton. But if we take a look at one of the problem springs, it's got the little glyph next to it indicating that it is assembled to an under-constrained component. If I edit definition for that one and then go to the placement tab, it is assembled to an assembly axis from the intake valve and also to a surface from the skeleton. Again, if you can assemble everything to one component, that would be great. So rather than edit definition, another thing that you can use is edit references. And instead of using the axis from the intake valve, we're going to assemble this to an axis from the skeleton. And I will select the A21 axis, then click the OK button. And let's do the same thing for the other spring. I'm telling you, this is a really, really tricky assembly. It's got a little bit of everything in it to challenge you to figure out what is going wrong. Let's click the OK button. And now if I go into applications, mechanism, hey, we did not get any error. Let's now put in our gear pair connection. So for our gear pair for the motion axis 1, I'll select this particular axis. I want to have the cam intake drive the exhaust. And then for the pitch circle diameter, this is where I can paste in that value. Oops, I have a leading 0. Let's get rid of that. It wouldn't cause a problem, but might as well. Now for gear 2, let's select the connection for the other pin axis. And then for the pitch circle diameter, let's once again paste in the value that we copied from the measurement. I'm going to click the OK button for a second and show you that. Let's clean up the screen. Let's turn off our axis display. Let me go to mechanism display and turn off the display of the joints. You can see where the gear icon is on the computer screen. I actually want to change that. I want to change where it's located so I can edit definition of the gear pair. And then for gear 1, I can use the pick icon to change the axis location to this surface, or rather the icon location. And then do the same thing for gear 2 for the icon location. Let me select this surface, click the OK button. And just so aesthetically, I find it a little more pleasing if the gear pair connection is shown where the actual gears are. All right, so now we can test the motion. Let's go to the drag button and then click on here. And hey, this is finally moving the way that I want it to in terms of the pin connections and the gear connections. Let me turn on my joint display again so I can select this joint. And then from the mini toolbar, I can create a motor. Let's change the profile from angular position to angular velocity. Let's do this 90 degrees per second. Hit the check mark for the motor. Let's now go to our analyses, create a new analysis. I'm not going to change the name. Let's change the type to kinematic. Let's have this run for 16 seconds. Oops. Let's have the end time be 16 seconds and frame rate. I always like to crank that up. Let's use a snapshot for the starting position. We're going to have our motor operate from start to end. Hit the run button. There we go. So now we've got the pin connections and the gear connection working after we broke a whole bunch of improper assembly connections. So yeah, a lot of repair work on this particular assembly to get the mechanism working. Next step, we'll work on the cylinder connections for the pistons and then try to get some cam connections going to have the actual cams move the pistons, or actually the valves, up and down. I hope you enjoyed this video. For more information, please visit www.creowindchill.com. If you learned something from this video, give it a thumbs up. And if you like this video, please click the subscribe button and ring the bell to be informed when new videos are uploaded. Thank you very much.